I just want to say thank you, thank you, thank you. That's it.
My pleasure. It's been fun setting this up. As Hallie said, she asked me a couple of months ago whether I'd be willing to talk about this. The original talk was going to be much more about the social and political implications of vaccine development, but we seem to have resolved those. So I'm going to talk about vaccine development today. Remind you that we have a bunch of people on, so if you're not asking a question, if you can turn your mic off, that's so helpful. If you have a question that you want me to answer, if you put it on the chat, I've got the chat going in a separate window. I'm going to start a screen share, and ideally you will be able to see what's going on my screen. And I am going to start a PowerPoint presentation because this really calls for that. So, and ideally we will be able to see pretty much everything. So somebody just check in orally. Can you see my screen, and does it say something along the line of COVID-19 vaccine choices?
We are good to go.
Looks good, Larry.
All righty. Can you hear me okay?
Yes.
Yes, sir.
Okay.
Yes.
All right. All right. So here's the talk. That's me. I was starting on the talk, and my younger son, who's living in the same place that I am right now, came up and said, "You're giving a talk on COVID. Do you actually know anything about that?" And it's like, where have you been my entire life? So I just want to say, for the background, this slide, that's a picture of the Walter Reed Army Institute of Research, where I did my first and second postdocs and worked for 15 years. One of the premier vaccine development organizations in the history of the world, based, obviously named for Walter Reed, who was a noted vaccine developer. And our creed is an ounce of prevention is worth a pound of cure. So whatever disease we were working on, we accepted that there were people who wanted to cure it, but we wanted to prevent it. So that's our job. I'm going to name drop right now because I can, and they're going to be out of the administration soon. That fellow over there, Bob Redfield, was my first boss when I was doing AIDS research. He's since moved on to other things, as you may know. And her, you normally see wrapped in some sort of beautiful scarf because she was the world ambassador for AIDS, and so has traveled all over the world after she left the military. She is part of the COVID task force. Debbie Burke's my boss. So, but right now I'm retired, so those are just people I know. I have no affiliation with any of their organizations. So want to talk about coronavirus infection and how it works. I expect to spend about 15 minutes total talking about how vaccines work, because you're not going to understand coronavirus vaccines if we don't talk about vaccines in general first. And so general stuff first, and then we'll get to the actual coronavirus vaccines. This is how coronavirus infection works, all right? So the first thing that happens is an infectious particle comes in either an aerosol or a droplet, much more rarely from surfaces, and it somehow gets to your body. All right, through your nose, through your mouth, or actually fairly often through your eyes. All right, it binds to a receptor, which is a molecule on the surface of many of your cells. It's called the ACE2 receptor. And these receptors are found throughout your nasal passages, in your lungs, and actually many other places in your body, including your gastrointestinal tract and your brain. All right, once the virus binds to those, it gets on the surface of your cell and it drops its package of mRNA into your cell. Let me go back into your cell. And that genetic code, its mRNA, uses your cell to make new viruses and proteins, and your cell becomes a factory for virus production. All right, until it kills your cell, which it will do eventually. So the consequences are that the virus takes over your own cellular machinery. The sorts of immunity that your body uses to prevent this sort of thing, the first is the innate immunity, with like your skin and the secretions that come from your, the tears and mucus and saliva and so on that try and keep viruses out of your body. And this is how we are preventing COVID right now. So here's your public service announcement: wear your damn mask, stay away from other people, wash your hands, okay? Okay, you can help your body by reducing the viral load before your body actually has to do any work if you just wear a mask. But let's assume that you get some sort of exposure to this pathogen. So over here, there are all these things that are definitely trying to kill you all the time, viruses and bacteria and so on. And the way your body deals with these pathogens is once they get into your body and infect various cells, you have an active immune system that recognizes that given pathogen. And your active immune system does two important things. There are lots of others, but there's the ones we're going to focus on today. This arm of the immune system makes antibodies, and antibodies bind directly to the virus, and they can soak up some of the virus and remove it so that it doesn't infect you. More interesting to us for vaccines is this other arm of your immune system, which coats cells with receptors, so molecules, that are specific for the COVID that kill your cells that are infected. And this is critical because this is where the majority of the virus comes from. It comes from your own cells that have been taken over by the virus. So these are called CTLs for short, cytotoxic lymphocytes, killer cells, killer T cells that kill your own cells that are infected. So these are critically important for COVID vaccines. And then just a really quick discussion of these things, these molecules, so that if I use these words, they won't have come from nowhere. So in immunology, we call anything that enters your body from the outside an antigen. This can be anything from ragweed, right, to a heart transplant to COVID. These antigens have molecules on their surface, and this is what your body recognizes, these various features on their surfaces, all right? And we call those are called epitopes. So that's the specific part of this thing, this virus that your body recognizes. So that's the target. Now, this can be anything, as I said. This can be just this laundry list of sugars and whatever, polystyrene. But we're interested in protein. So I've starred this, and that's my marker to remind me to point out that today we're talking about proteins. All right. Now, 3 quick slides on how amazing your body is and why vaccines are better than drugs. The first thing is, this is an antigen. Remember, that's the part. This is, in fact, part of the flu virus. And this is an antibody binding to that. The first thing is that the specificity is so incredibly amazing, it's almost impossible to describe. When I was taking biology a half century ago, all right, we called this like a lock and key. And now we know it's like 20 locks and keys all at once. So this is so incredibly specific that imagine 20 different locks and how hard that would be to do it. Your body does it all the time. The second thing is that the binding between these things is unbelievably strong. So the binding is on the order of 10 billion, which means for every virus particles in your body, if you have the antibodies there, for every 10 billion of them, one escapes detection. All right. This binding is the strongest that we know in nature, actually. So antibodies can bind stronger than anything else that we know. And the last thing is that your body is amazing in its ability to recognize foreign bodies. The point is that this is how we stay alive against all those things out there that are trying to kill us. And so the current estimate is that your body right now, from the time you are born, can recognize on the order of 1 billion different things, 10 to the 18th, 1 billion different epitopes on viruses and funguses and so on. So let's get to COVID. That is a picture, it's a cartoon, but it's based on actual knowledge of the SARS-CoV-2 virus. So that's the one that we're talking about now, COVID-19. That's a picture of the virus. And the virus has a couple of things that are worth noting. So coronaviruses have a membrane. This membrane is made out of lipids or fats. It's like your cells in that it has a membrane. Not all viruses do. This makes the virus weaker, which is why it spreads a little bit more easily when it's cold outside and doesn't persist on surfaces very well. So even though we did an absolutely horrific job of dealing with what could have been a good time this summer, it's going to be worse in the wintertime because these like cooler temperatures. Cool temperature helps maintain this membrane. And then we have proteins. And COVID has proteins that are outside these things here and proteins that are inside. There are proteins in here as well. And it has a specific genetic material. Its genome is made out of RNA. Not like you, your genetic material is DNA. And some viruses use DNA, but some use RNA, and COVID is one of those. For vaccine development, we're interested in both the RNA and the external protein. This is it. This is our target. You've read about it. You love it. That's spike. Spike the protein is what coats the outside. And spike the protein looks like this. In an amazing display of scientists working together and getting it right, for over a year now, we have known the sequence of the coronavirus RNA, and we have pictures, actual pictures of what spike looks like. This is spike, all right? And this, although it's a cartoon, it is based on the actual crystal structure, the known structure of spike. Coronavirus COVID-19 is covered with spike. So this is the first thing that your body sees. Spike is what binds to the ACE receptors on your body. And spike is what binds to those receptors and allows the virus to get into your body. So spike opens up your cells and allows the virus to enter your cells. It is the target for vaccine development. There's a lot of it on every virus particle, right? It's the first thing that your body sees. And it is what we believe antibodies against spike are what protect you from COVID. So spike is it. All right, I'm going to stop for just a second. Is there anything that's so non-obvious that I should stop and deal with it right now? I don't see anything in the chat, and I'm looking. All right, somebody just check in and say hi, so I know you can still see me because I'm just looking at a PowerPoint.
Hey, looking good.
All right, still there?
I got you, Doc.
There? All right. So take a deep breath, take a sip of coffee. All right, here we go. We're gonna vaccines work. All vaccines do two things. They rev your body up so that your body makes those specific antibodies against the virus in this case, and they stimulate those killer T cells, the cytotoxic T lymphocytes. Every vaccine that we know that works makes antibodies against its target. The best vaccines also stimulate T cells, all right? Those are these killer T cells. Not all vaccines do as good a job of that, and the ones that don't do a good job of that aren't very good vaccines. And in the history of vaccine development, the only ones that could do that were the live vaccines, all right? So the ones that were caused by actual infection with an infectious vaccine. So we got to talk about this because this has changed in the last few years. All right, so this is how a vaccine protects you. A vaccine protects you essentially the same way that getting infected protects you. This is what your body does when you get an infection. Very early on, your body recognizes that foreign thing, that virus that's in your body, and you start producing antibodies. And then you get a big rise in the antibodies that are protective. These aren't protective necessarily. These are just the ones that rev up your immune system. But this right here, boom, that's what gets you better. So let's say you got a cold. This is when you got exposed to the cold and you're sick for a while. And then, you know, a week to 10 days later, you get better because your body has made the immune response. Well, okay, so you go back to school And then you get exposed to that cold again because one of your friends has got it. What happens is your body makes a rapid and very strong specific immune response that keeps you from getting sick again. But you were exposed and you did have that virus in your body. Your immune system doesn't keep you from getting exposed or even from getting infected again. It keeps you from getting sick. And that's what vaccines do. So, if,
Larry?
yeah, go.
Is that how the flu vaccine works?
Exactly right.
Okay.
So vaccines do this. They skip the first step. So you get the vaccine, instead of getting sick, what happens is you make the immune response against the virus, even though you haven't seen it yet. And then when you get exposed to the virus gets in your body, revs up your immune system, and you don't get sick, or at least you don't get very sick. A year ago, I got the flu vaccine and my son got the flu. And I got the flu for about 24 hours when I got exposed to his virus. So the vaccine prevented disease. It doesn't prevent infection. It can't. All right. So how do vaccines, let's say it again another way. What vaccines do we have available right now today? So if you go to your local CVS, you can get vaccines against a variety of different diseases. I used to travel a lot, so I got polio vaccine, all right? So I actually got a live vaccine, the Sabin vaccine. So this was polio that had been weakened so it didn't cause disease, but then infected my cells and made me immune to polio disease. The influenza vaccines that we have, the Loomis that you get up the nose, is the same thing. It is a weakened version of flu. Or we have a lot of vaccines that are based on a whole organism that's been killed. The Salk vaccine against polio is dead virus. The injectable flu vaccines are dead virus. The new vaccine for West Nile virus is dead virus. So they take real virus, they chemically treat it so it can't infect you. They give it to you in the muscle, and you make all your antibodies and so on. So these are the ways that the vast majority of vaccines in the history of humanity have been made. They rely on the organism themselves, and they are dangerous because sometimes you can actually get the disease. And there was a failure of the Sabin vaccine early on, and gave a bunch of kids polio, right? And so we don't things that can kill you, because if you make a mistake, you give a vaccine to somebody and it could kill them. We don't use these right now for coronavirus. So we have instead moved to new technology. And instead of giving the whole virus, what we do is we give a part of the virus. So these vaccines, I've got the hepatitis B vaccine. It just uses one protein, a surface protein like spike. All right, protects against hepatitis. Can't get the virus though, doesn't have the whole virus, has no genetic material, just one protein. The new papillomavirus vaccine that prevents cervical cancer, same thing. It's a part of the virus, not the whole virus. So let's see, question. So if I get a vaccine and it keeps me from getting sick, but I am exposed, can I give it to others? And the answer is we don't know, but yes, probably. Yes, probably. So if you get the vaccine, all right, and you get exposed again, you will probably harbor the virus for a short period of time and could theoretically pass it on. That's theory. We don't have a lot of specific data about that. Okay, so I'm going to say yes, but we don't have verification of that. Okay, so there are some COVID vaccines that are developed using this. I'm going to talk about the current leading candidates today. Now, let me just go through this quickly. The vaccine process, when it's done right, requires an enormously complex set of processes to make sure that we have a vaccine that is safe and that works. This requires trials that are well done, that are huge, that have been done long enough, that are, you know, have oversight by people who are not invested in it. And generally they take multiple stages of testing, including animal models, and then a small phase 1 to make sure it doesn't hurt people, and then a bigger phase 2, which still makes sure it doesn't hurt people, and then the big phase 3 trials that make sure it doesn't hurt people and that it works. This process over time and throughout my career has taken 20 or more years from the time that you decide you want to make a vaccine until you have a working vaccine. 20 years. 20 years. Efficacy means, does it work? So efficacy right here means, does it work? Does the vaccine protect you? Okay, so efficacy, work. So the COVID vaccine, we discovered COVID, you know, more or less January of last year, and we have finished phase 3 trials against COVID, which means that we have reduced the amount of time that it takes to get to a vaccine by 95%, which is amazing and frightening in some ways. And I'll talk to you about why it's both amazing and frightening. But there it is. That's how we've done it. Not me. I'm not doing these studies. I'm just telling you about them. So here are pros and cons of the vaccines that we need to talk about, any given vaccine. The first one is, can you get the disease from the vaccine? Is it infectious? And the answer is nice blue happy circle, no. Okay? You can say without doubt, not 99% confidence, 100% confidence, it is not possible to get COVID from any of these vaccines, period. Blanket statement, can't get it. How about short-term side effects? Well, if the vaccine has been through a phase 3 trial, we know about the short-term side effects, and some of these vaccines have known side effects, but at least we know them, something that we know. How about those long-term side effects? I'm going to just say right here, big red circle, we have no freaking idea. And nobody can say that we do. It is possible that there are long-term side effects that will show up anytime, from a year from now to 2 years from now to 10 years from now. These studies are all going for a minimum of 2 years of follow-up because we know that there are likely to be some side effects, but we don't know what they are. Also, this sort of thing, the interactions between the vaccines themselves, getting COVID, long COVID, we don't know. We don't know. The studies haven't been done long enough. So this is something that we just don't know. Question, were there vaccines for the past coronaviruses? No, not tested in humans. They were vaccines that were developed, but the specific epidemics of those disappeared before the vaccines were fielded. Here's efficacy. Okay, so I'll define efficacy better now. Efficacy is the percent of people who get the vaccine who are protected. We know this for several of the vaccines right now. We know it. How long does the vaccine work? We have no clue, no circle, no idea. Is it 3 months? Is it a year? Is it 10 years? Probably not 10 years. I hope it's more than a couple of months, but we don't know. How does it vary by race, gender, age, and so on? Some of those studies are being done. Some of those are being done right now. So was the vaccine tested in kids? None of them have been tested in kids yet, but are they tested in seniors? Yeah, they are. Variability over time. Is the virus going to change? Yeah, coronaviruses change over time. Will the vaccine prevent against the virus after it's changed over time? We don't know. Probably not, but we don't know. And then the other concerns, and several of those showed up. How much is it going to cost? I don't know. Does your insurance cover it? Right? We don't know. How do you store it? Turns out to be a big issue for vaccines, especially one of the ones that we are going to field right away, right? Storage is an issue. How do you get it? All of these we get by being shot in the arm, all right? That's not our best mode of delivery, but we use it a lot. Can we modify it to make a better vaccine or a different vaccine in the future? Yeah, these platforms are pretty easy to modify, so that's a good thing. Okay, I'm going to stop again. Just do a check-in. Everybody still there? Can you hear me?
Yes.
Yes.
Yeah? Okay, because I'm going to start talking about particulars. This was the background. So
Carry on.
I want to talk about trials. Okay, the best mode of delivery would be to wave a magic wand and say you're now vaccinated. The next best one is oral, because people like pills. So getting a shot in the arm, people don't like very much because it hurts. Okay, here are the vaccines that are in trials right now. There are no weakened organism vaccines being tested in the world right now. There are some killed organism vaccines that are being tested, but not in the United States. They are potentially dangerous, and the FDA is not going to approve killed organism vaccines for the United States, period, end story. China is using them though. Vaccines that are based on pieces and parts. Yeah, there are several. You've heard about Novavax. That's one. I'll talk about it. And there are two completely new methods that have not been tested in large-scale trials in COVID. The first is based on RNA, and both the Mrna and the Pfizer vaccines that are, right now, RNA. The other one is using a virus vector, and AstraZeneca and J&J represent those two. There are many, many dozens of vaccines being tested in the world right now, right? Crazy number. But these are the ones that are in phase 3 trials, which is human efficacy, all right? I want to talk about the mRNA vaccine because it's new and it's cool, all right? This is, biologists believe everybody has a dogma in their field, something that we believe in. We believe that the genetic material in your body, DNA, makes RNA, which is an intermediate molecule that makes the proteins that make us up. You're mostly protein. All right. So this mRNA makes proteins. And the point of an mRNA vaccine is to skip the whole protein step. So the way we do this is this is COVID. This is the RNA of COVID. And these are the parts of that RNA that code for different proteins. And that part right there, that codes for spike. So suppose you had the ability as a biologist to cut out that little piece of RNA, all right, and take it away from the virus and put it into a vaccine, all right? So that right there is spike RNA. It's not all of the virus, it's just spike. And you put it into some fats, so it looks like a little teeny tiny cell. We call that a liposome. And you inject that into an arm and see what happens. Well, as it turns out, that liposome, that vaccine, enters into your cells and it dumps the RNA into your cells. And just as if it were a whole virus, your cells make the proteins. How cool is that, right? And so your cell starts to make spike protein. It's not going to make you sick because it doesn't make a virus, it just makes spike. And so your cells take over making antibodies against spike and making killer cells, CTLs, against spike. What a brilliant way to help your body make all of these necessary responses against spike without risking making you sick. Amazing. Now there are some downsides. RNA is just a bear of a molecule. It's really fragile, so it just decomposes. So Mrna and Pfizer have dealt with this in different ways. One of the ways is to keep it cold, all right? And that's an issue because they need to be kept really cold, and ideal vaccines wouldn't need to be kept in the freezer, and these do. It used to be that these vaccines in my time period, they didn't make much protein. That's been fixed. They're good. They make a lot of protein. Downside is they tend to make you feel bad. Vaccine, you tend to get a little bit sick. It's not COVID, but sick is bad. Nobody wants to be sick, right? So this is a downside. And there are two things. I'm going to lump these together right now. These are new. They have never been tested in people before, right? And we've been testing vaccines in people now for close to 200 years. And this is new. And here comes the warning. We don't know what we don't know. We don't know if there are going to be long-term consequences. We just don't know. We have no way of knowing until we inject these in a bunch of people and see what happens. And so if you are risk averse, you need to know that these vaccines are new. All right. So here are those vaccines, those mRNA vaccines, and we've been getting a lot of press on these. The Mrna mRNA vaccine. All right. The whole trial, 30,000 participants, finished in October. It's been reported. It's been on the news. This was tested in adults only that hadn't been infected as far as anybody knew. It requires 2 doses about a month apart or longer. Okay, it's a downside. We'd rather have 1 dose. It's easy, but this is 2. And in the trial, there were not quite 200 infections, of which the vast majority were in the group that did not get vaccine, the placebo. And of the severe responses, so people who got COVID, 30 had severe COVID disease out of that, which is the number we've come to expect, right? About 5-6%, and 1 person died. Many fewer infections, no severe, no deaths in the vaccine group. As a vaccine developer, you look at that and say, oh, okay, that's everything that I wanted. 94.5% efficacy. We were hoping for 60%. 60% would have been considered viable. 94.5% is crazy, just crazy. They had minorities involved. They included seniors. They, as I said, are continuing for 2 years to look for those long-term effects that we don't know about. There were moderate side effects. All right, it hurt. People had immune responses that didn't feel good. And that is something that people will talk about, and certainly anti-vaxxers will grab a hold of, but it's not COVID, it just hurts. And for the Mrna vaccine, they require liquid nitrogen freezers. Now, when I was doing research, we had a dozen of these in our laboratory, but the average hospital may have 1. Smaller hospitals won't even have 1. So delivery of this vaccine is an issue, right? It's not going everywhere. So they expect 20 million doses of this to be available this month. It's one of the warp speed targets. If you want to look up any of these vaccines, we'll figure out a way to post this, but you go to clinicaltrials.gov and you can look up any of the vaccines by the name of the company. So that's the first one. I'm going to finish the other mRNA vaccine and then answer mRNA questions if we got any. Pfizer, which I misspelled there, sorry, there's no E in their name. The Pfizer vaccine, the report came out essentially the same time as Moderna, bigger trial, all worldwide. They immunized children starting at age 12, beautiful, also seniors. The Pfizer vaccine required a couple of doses. But very similarly, the efficacy was 95%. And they reported that there was no difference in seniors, which is brilliant because we, as we get older, don't respond as well to vaccinations in general, but the seniors did in this trial. All of the severe, 90% of the severe responses to COVID were in the placebo group. So good protection, super, super good protection. And let's see, more details on this. Follow-up continues for 2 years, right? Long-term effects. Lots of side effects, okay? So people got tired, they got a little sick, they got headaches, it hurt. But the vaccine can be stored in the refrigerator. It has to be frozen in general when you ship it, but once you've opened up a vial, it can be stored in the refrigerator for a week. And they expect to have 50 million doses this month, also a warp speed. So here's what we have about mRNA vaccines. They are ready now, right now, all right? Frontline workers are going to be, getting immunizations. They're already getting immunizations in the UK. But they're new. They're new. They seem to protect really well. We don't know how long they will protect people for, and we don't know if there might be long-term side effects. We don't know if they are going to, what it's going to effect it'll have on long COVID, for example. We don't know. We just don't know these things yet. So those are the mRNA vaccines. I don't see any questions in the chat, but I think it would be good to stop for just a second. Anybody got a question about the mRNA vaccines before we move on?
I just wanted to comment that I watched a 60 Minutes segment on vaccine delivery, and they're using dry ice as a big part of their plan. The Army is, so it is going to enable some of those ones that need storage to travel in many places.
Yeah. So we don't know, since mRNA is such a fragile molecule, it depends on the formulation, and the formulations are all proprietary, so we don't know how they're made. But you know, the Moderna says it needs to be stored at -70, and I'm going to assume they know something that we don't. Dry ice doesn't get you down that cold. It probably will help stabilize the vaccine, but you know, they say -70, and I'm going to believe them until they say otherwise.
Larry, can you define spike?
Spike is the surface protein of the coronavirus. So spike is a protein, and it's the, when we look at the virus and it looks like a crown, that's what coronaviruses are named for, crown. The crown, the things that stick out from the virus are the spike protein, and that's our target. It's our target for vaccine development.
Also, one other question, is it possible to have tested positive for COVID and been symptomatic? Because I'm asking about myself, actually.
Uh-huh.
And my 5 days after I went off isolation, and I was basically isolated for 18 days, I still testing positive. And she said, and my PA said, well, it takes some people a while to turn to negative. Are there people that never turn negative?
That's a great question, and I don't have the answer to that because there aren't any reports of what do we call them? COVID Charlie, COVID Carl. You know, somebody who spreads it. We don't know of that. We don't know of that, but it does. The tests are really variable. I mean, they've all been developed this year, right? And so some of them are not very good. Some are better than others, but we just don't know everything about the testing. It's really new. And so I get a little bit flip about the testing. The fact that we have these tests is truly, it's miraculous. It's unbelievable. So the fact that they aren't perfect yet is to be expected. So,
are these the very first mRNA vaccines?
We have been talking about mRNA vaccines for 30 years, and none of them worked worth a damn, nowhere. But the mRNA has been modified substantially in the laboratory. We can stick around and talk about that afterwards if you want, but it's kind of technical. And yeah, I mean, we've done teeny tiny clinical trials, like phase 1 with 10 people with other RNA vaccines, and we've never had anything that looked as good as this, except for the vaccines against the previous coronaviruses, which used this mRNA technology. Now, they were only tested phase 1, you know, but yeah, they're completely new under the sun.
Good timing.
Larry, this is Mary.
Yeah, go Mary.
What if you have diabetes? I mean, did they test people that had certain issues?
They did. They tested for people who had comorbidities. And so you'd have to look and get the specific data, which I don't have. They haven't unwrapped all of that data yet.
Okay.
But they, you know, I volunteered for all of the vaccine trials and was turned down over and over again because I didn't have, you know, the right comorbidities and so on, and not high enough risk now that I'm retired. So, but they did look for underlying conditions, including diabetes.
Okay.
All right.
Yeah.
Good. Great questions. Thank you. All
I
right.
have a question about the Pfizer vaccine.
Uh-huh.
What happens if some point in transit it gets too warm? Say it gets to 0 instead of the 70 below.
It would theoretically degrade the vaccine, and they would be required by law to destroy all the doses.
Wow.
Right.
How are they going to know?
They keep track of this. Oh, they keep track of it. I was involved in that, in the storage. you have a freezer log, you do real-time monitoring of the temperature, and if it gets above a certain temperature, everything is thrown away.
Okay.
All right.
Do you have any immunity
Thank you.
before the second shot?
There was some immunity. All right. They didn't report that. They didn't break it out yet, but they will have data about people who may have been exposed between the first and the second shot. They won't have a lot of immunity, but it's possible they have some, and that's something they'll be unpacking over the next couple of years.
Okay.
All right. So this is the other one. One of the questions on the chat was talk about vectors. Okay, so this is the other major new approach for COVID vaccines, which is the viral vector. Suppose instead of using a liposome, you take that little RNA for spike, right? So this is the bit of the genome from the COVID that codes for spike protein. And you take that and you put it into a different virus, not COVID. Let's say, just a cold virus or something other virus. So you start with the RNA from spike and you put it into a cold virus or a virus that you got from chimpanzees or something like that. So something that doesn't cause disease in humans, but can infect you. All right. And then you make sure that virus can't make you sick. So if you use a cold virus, maybe you disable it, you weaken it in some way. And then you give that to people. What these vector vaccines, so the vector is the carrier for the spike RNA, they enter your cells, so they're competent to do that. And then they go through a round of making proteins. And so your cell will make spike, but they cannot make more virus. They can't even make this virus. This virus has been made incompetent. It can infect you, but it cannot make new viruses. Only the proteins from the virus. So spike protein. All right, so the idea is let's make a virus that can't give you a disease, but can give you immunity against COVID spike. All right, and so at the end of the day, we have this vector virus that makes spike protein, but cannot make you sick because it can't replicate to the point where it can infect other cells. The only thing that can infect your cells is the vaccine itself. Well, the good thing about that is it gives you good immunity because it's a virus. Your body hates viruses, makes strong responses, makes a super strong response. In fact, one that can be strong enough to make you a little sick, okay? There's a downside in that if you've already had that virus, adenovirus is one of the ones that's used, and that's a cold virus. It reduces your effect because your body has already seen that virus, so it acts against it and reduces its effectiveness. And then again, we don't know what we don't know. These are new. There are no vaccines before COVID that have been tested in people. So, but they have some upsides, they have some downsides, and they are being tested in phase 3 trials in the United States, including the AstraZeneca one, which has reported some results. They gave an interim report in November. They're not done yet, but they had 40,000 participants, high-risk adults only, using an adenovirus that was modified from chimpanzees. So it was a chimp, gives chimps colds, but it can only infect your cells once. It can't keep going. So to that extent, it's good. I was wrong there. It's a single dose. And we don't have a complete analysis, but it looks like there was 70% efficacy. So not as good as the mRNA vaccines. The follow-up continues for a couple years. There was one serious side effect, which was a stroke, which was not associated with the vaccine as far as they could tell. 70%. They made a big screw up. They aren't admitting it, in the national news, but they were hoping to give a large dose and then a small dose. And instead what they did is give a small dose and then a large dose. And it seemed to affect how well it worked, which makes you just worry. Okay, so I'm going to say this has got big question marks. They're going to have to redo a bunch of this. What an incredibly bad mistake to make in a large vaccine trial, but a lot of this has been going very fast. And so they made the vaccine, they made the mistake. So this is would be the first vector vaccine ever tested in human beings in large doses. And we don't know, but it is likely to be available sometime in the beginning, couple months of 2021. And let's see. The Johnson & Johnson vaccine is very, very similar to that. So I'm not going to go to it in detail. This one is not going to be available until March anyway. Large number of participants, single dose. They used a cold virus, so a human adenovirus, to carry their spike protein. This is a rare one, so not as many people have had it. If you've already had this cold, though, you will be partially protected against the vaccine, a problem. They also had a serious side effect, but that has since been restarted, and it's under warp speed as well. So by midwinter, by the end of winter of 2021, we should have these two vaccines sorted out, and they will start being available for human use. And so of the 4 vaccines, the two that are ready right now are both based on mRNA. The 2 that will be ready shortly are based on the vectors. And the last one is the only traditional one that's even gotten out of the starting gate yet. This is one that uses a traditional way of making the vaccine. It's basically spike protein that's injected, just the protein itself. A typical vaccine dosing schedule, 2 doses, 21 days apart. And it's safe in small trials. It makes antibodies in small trials. And they are still recruiting for this, so we aren't going to have that available until at least spring of 2021. This, I would say, is the most traditional vaccine that's going to be available in the United States, but it is not available now and won't be available for a while. So that said, if the question is which vaccine, I'm going to ask you some questions. To survive, we're going to have to get vaccinated. Okay? If we don't get vaccinated, community immunity is not going to kick in until we have between 3 and 10 million dead Americans. Anybody who says that we should do that is talking about genocide against America. Community immunity has no place in medical discussions of COVID. All right? The death toll worldwide would be appalling. The death toll in the United States would be unacceptable. We'd have to get about 2/3 of our population immunized before we can get to community immunity. I hate the words herd immunity. Humans aren't herds. We are a community. So you may not have a choice. Questions came up. It's like, okay, will it be free? How fast will it come out, and where will it be available, and all these kinds of things. Whether or not you even have a choice may depend on what insurance you have and what's available when. There is a very fun website through the New York Times. I recommend you go to it, and they'll ask you a question about yourself and says when you are likely to be able to get the vaccine, assuming that we're still having to choose vaccine. And I'm in the last 10%. I was number 6 out of 100. So the last six from the end. And Stephanie was the very last person that they would give a vaccine to, because we're, younger and not in high risk professions. So we're not going to get the vaccine soon. Your insurance company may help you choose. But I will say that from my point of view, I'm going to get the first one that's available to me. But I was willing to sign up for a trial. And the question I will kick back to you is, how about you?
Yeah.
So I am going to stop the share so I can see faces again. Hi, everyone. And I have other information that I can share. It is time, though. So my feelings will not be hurt if your screens start to flicker out. but I'm willing to stay as long as the church will host the Zoom session. And ask me questions. I'm looking at the chat, and I've gotten to several of those questions already, but go if you have a question.
What about the, Leon, what about the second dose tracking? In other words, like say I go to my physician and I get it there, or to
Yes.
CVS, and I get the first dose of the vaccine. Will there be a system for following up to see that I get the second dose?
That is a great question, Sharon. There should be, because the ones that require 2 doses require 2, so you need to get the second one.
Right.
And it does you no good, really, if only the first dose is available. So that's one of those things that's going to be dealt with by insurance companies, and you know, we're moving this along so fast that.
And is Medicare going to be a primary in terms of coverage? We don't know.
We don't know yet. We don't know yet, right? They're not going to be available to most of us, you know, for a couple of months, you know, so they're still working on those issues. Great questions, but just don't know. Next,
Yeah, I'll sign up for a vaccine study. In fact, I volunteered for the first one, like in August or whatever. And
Yes.
for the COVID study, I wasn't eligible because I wasn't exposed enough, and I live by myself and all of this.
Right.
Then I signed up. Then they called me again because I was in their database by then. They knew that I would be willing to do a vaccine. Then they called me about the chikungunya vaccine. I wasn't eligible for that because I had an elevated CRP level. And so then she called me just Friday again. Well, we have another COVID study. Are you interested in probably participating in it? So I've been screened now for it again. So we'll see what happens, because I am going out more. I'm doing a little bit more now. So I may be able to do it now because I'm more at risk, I think, now than I was in August or whenever it was. So
Yeah,
we'll
I'm
see.
jealous, Carla,
See what
because
happens.
I've signed up a bunch of times, and they keep, a lot of them don't even bother to contact me back.
Okay.
And the
Okay,
one
yeah.
is
Well,
like-
I'll see that, because I just completed my pre-screening stuff. So we'll see what happens. I don't
A
know.
middle-aged white man, you know, with no comorbidities and you know, and retired. It's like,
Yeah,
oh,
well, yeah.
go to the end of the line, right?
Yeah, I know.
Go.
I do have at least one comorbidity, so yeah.
Yeah, which is bad for you, but may help you get into a vaccine trial.
Yeah.
Go ahead, Kate. Yeah, I see a hand up. You want a question?
Yeah, Larry, do you know anything about what else is in the vaccines, like stabilizers and preservatives?
Yeah, so the nature of the formulations right now is that they are largely proprietary. These vaccines, though, because of their nature, don't need the same sorts of things that previous vaccines did in the way of the additives that either preserve them or increase their efficiency. Previous vaccines needed to have something called an adjuvant, which helped rev up your immune system. And we've used things like alum, so it's aluminum particles, and those adjuvants cause an increase in your immune response, and so they often cause immediate side effects. You know, they make them more painful, and they give you the flu-like symptoms and so on, because that's your immune system getting revved up. Inflammation, which, you know, we take Motrin to stop inflammation, right? Because we hate it. It makes us feel bad. But a good vaccine has to cause inflammation. Otherwise, it's not working. So previous vaccines have had to weigh that. The mRNA vaccine and the adenovirus vaccines, as far as I can tell, don't have to add a bunch of stabilizers because they don't add adjuvants because they go right into your cells. So they're not trying to get your immune system to cause a big inflammatory response. They're just, you know, getting the package into the cells. So the last one that I talked about, it wasn't the Johnson & Johnson, it's the one after that, the one that's not available yet. We'll have to see. They have a way of putting together their vaccine particles that hopefully won't require an adjuvant either. And we've been, as a society, we've been moving away from them because those stabilizers and those things, sometimes people have reactions against them. So they've been taken out of most vaccines.
Professor,
Yeah, go Colm.
if you do a trial, are you ever told if you got the placebo? And at what point? Because then you need to, do something.
Yeah, that's one of the biggest, that's what gives ethicists their major job in the United States today, dealing with questions like that. So the short answer is yes, they eventually tell you. The longer answer is they cannot tell you until the trial is completely unblinded. And that means not just you and your doctor, but all of the people that are doing the analysis, right? Because you can influence data analysis way down the track. My guess is that the two trials, the mRNA trials, are being unblinded now so that the participants are being notified. And in the trials that I participated in, people who participated in the trial and were given the placebo were at the very front of the line to get the actual vaccine. It was one of the inducements that could be given, right? It was one of those ones that was ethically believed to be related enough that you weren't, inadvertently skewing who might sign up for the vaccine. So they eventually do tell them, and hopefully they'll be giving them the opportunity to get the vaccine if they didn't get it as part of the trial. It's a lot of doses though, right? We have, close to 100,000 people, which would burn up every single dose of vaccine that's expected to be available in the next month. So, right? It's a good question to chew on, good ethical question there.
Where are they measuring the efficacy along the road of between shot 1 and shot 2?
So each trial has a required number of check-ins. If you show any signs, obviously you go to your doctor, and the doctors are participants. So they check to see, it's like, okay, take your temperature, give you a COVID test and so on. But I don't know, they also do a check to see if you've become infected but weren't symptomatic. But as we all know, those tests they're fraught, right? Even the good ones are not 100%. So there probably were some asymptomatic infections in the trials, and maybe some of those weren't caught, right? So, but they do them throughout the trial, and they will continue to do follow-ups, right? Those 2 years. So hundreds, well, way more than that, millions now of people worldwide are in the healthcare system being monitored for COVID as part of these various trials. Good.
Wanted to highlight a couple of questions in the chat that I think got buried.
Oh,
one
sorry.
was, will we need to have the same vaccine that our community gets? And the other one is, what about the effect of vaccines on pregnant women?
Two extremely good questions. The first is, we're going to have a community that's gotten a variety of different vaccines. All right. And so that is going to be one of those crazy things that societally we're going to have to be monitoring and working out. And in terms of what we don't know, if you get one vaccine this time around, will it affect your response to the next time you get vaccinated? Because we are going to have to be vaccinated periodically for this. The virus is going to change. Coronaviruses do. So this could well be the sort of thing where we all need to get vaccinated every year for the new strain of coronavirus. Could well happen. And so, hey, this year I had to get the mRNA vaccine because that's all that was available. But next year they've got a protein-only vaccine, and I have, a fondness in my heart for those vaccines. So I'm going to go get that one. How will that affect the likelihood that I'm immune? Nobody knows. The next generation of scientists are going to be, that's going to be something we're going to be learning for 2 decades, probably, right? So that's new. The effect, pregnant women or women who might become pregnant were excluded from these trials. If you were to be in this trial, you had to be not, test on effective birth control and sign a statement that you did not intend to become pregnant during the trial. So right now we have no information. And so that is I am not a medical professional. I'm, was a professor of biochemistry. Talk to your doctor before you do anything having to do with vaccination when you're pregnant. Okay.
Larry,
Yeah.
what about cancer or, liver issues or things like those? I mean, that,
Right.
did you have people in the study that had really major issues?
Those
Besides
were mostly excluded from the study. And the reason they exclude those from the studies is that there are specific conditions that reduce your immunity, and they
Yeah.
were trying to look at what's going on in subjects that have more or less normal immunity. But if
Yeah.
you're on anti-cancer therapeutics, your immunity is known to be suppressed, right? So
Right.
that's a real big problem. And we're not going to know, folks who are at risk are going to have to get these vaccines sooner rather than later, because if they get COVID, it's going to kill them. So there's your choice, really. I mean, if your choice is if you get COVID, you're going to die, and the vaccine may have some unforeseen consequence, that is a difficult personal decision,
Yeah.
right?
So if you have an autoimmune disorder, that might be a good reason for you to have it versus not have it.
Absolutely, right? Right. Whether or not these vaccines might be involved in later autoimmunity is one of those really big red question marks, right? We're doing new things and people's bodies respond. A lot of autoimmune diseases appear to be the results of something that happened to you. I mean, you've got a genetic background that makes you susceptible, and then you got a virus that caused you to, it triggered your MS or your rheumatoid arthritis or your Crohn's or whatever, right? Could these vaccines play into that? Yes, right? They could. That's something that we're going to have to monitor and learn as we go. It's one of my biggest fears, but it's just a fear. There's no data. There are no data. There's a question that just came in relevant to before we end the talk. Would I not sign up for any of these vaccines? I wouldn't have signed up for any of them if the Trump administration had been allowed to keep its fingers in the pot, because I wouldn't have trusted the results. Right now, the politicians have pulled themselves out of the vaccine development. As far as I can tell, the scientists and the ethicists and the people that are supposed to be doing their work are doing their work. And so all of these vaccines, I believe, are equally safe, which is to say, as safe as they can be when we don't have any long-term studies. And as part of my duty to the community, I'm going to go get vaccinated, and I'll be vaccinated with the first one that's available to me, because it's part of my responsibility to humanity to not get and spread COVID. And the way I do that is by getting vaccinated, right? That is part of my ethical responsibility. Now, we all get to determine our own ethical responsibilities, so you'll make those choices for yourselves. But I would get any of these, and I will get the first one that's available to me.
Let's wind it up then. And anyone have one last burning question for Larry before we say thank you and goodbye? All right. Well, once again, we cannot thank you enough. Dr. Loomis-Price, you've been stellar. Absolutely.
That was great.
Thank you.
Thank you, Larry.